So at lecture, we just finished up with this slide. We just finished up with the fermentation, one of those kind of alternate ways of breaking down carbohydrates. Fermentation, again, is still going through glycolysis. It's still taking glucose. It's still making pyruvic acid, just like it does in cellular respiration. It still gives us some NADH. It still gives us a couple ATP. But the rest of the part of the fermentation process takes that NADH and regenerates and gives us more NAD+, which can go back into the glucose or go into the glycolysis cycle as a whole cycle itself, constantly going through the process to give it NAD+, which goes up to the top, which becomes NADH, and so on, going back around. But we're going to get away from catabolism. We're going to get away from breaking down of that glucose, because most of this PowerPoint was all catabolism. It was breaking things down, releasing energy in the form of electrons to make ATP. Now, the opposite part of catabolism is the building things up. And so we still have some anabolic pathways. We don't talk about them as much. I'm like, just because the catabolic is almost more important of where everything starts and where does it all come from. But an anabolic pathway, these are synthesis reactions. These are reactions that are building molecules. And to do that, it requires two things. It requires energy, and it requires precursor molecules, the building blocks. Before you build anything, you first have to have building blocks, and two, you have to have energy to put them together. And so these are the synthesis reactions that are going to use those two things to build things. Now, where does the energy come from? Well, the energy that comes, the energy that's used to put all of this together comes from the catabolic reactions. The fact that you broke things down to release energy, some of it stored as ATP, that's some of the energy that is used then to build other molecules that the cell needs. Now, anabolic reactions or anabolic pathways, the building things up, are almost always a reverse of a catabolic pathways. They can go both ways. It's called amphibolic. And I'm like, amphi means both ways on two sides, and amphitheater, it goes on the sides. Amphibolic means they can go both ways. And I'm like, this is showing how two smaller molecules, an A by itself and a B by itself, can be put together to make one larger molecule. You just built something called AB versus A and B. And so you, through one reaction, through an anabolic pathway, you just built something larger. Well, you can also take that AB molecule and break it apart into its two separate particles. It's A and it's B. There's a particular enzyme that will do each one. There's one enzyme that will build larger molecules, and there's another enzyme that will break those things down. Now, in your book and various books, this is just showing you, depending what your building blocks are, depends on what you're going to build. The smaller the molecules, the smaller the thing you're going to build, but those things you build could become more building blocks. And so we can take things like sugars and amino acids, and we can start making larger molecules like glycerol. This is usually fatty acids, making glycerol and other larger molecules. We can take individual elements and start building larger molecules. And then we can take some of these smaller molecules, although they're larger than here, and we can start building even larger molecules. We can take elements and make the nucleotides, and we can take nucleotides and put them together to make DNA, and we can put DNA together to make chromosomes, and so on. It's this constantly building of taking smaller building blocks and making larger building blocks. That's all our anabolic reactions. Now, this slide, I also kind of like to label it, but I don't put it on there. Although it's called Integration and Regulation of Metabolic Function, if I had to rename it into something that sounds more memorable, it's How Our Cells Like to Be Lazy. Now, the more politically correct would be how our cells like to be energy efficient. Our cells like to be lazy, and these are different ways on how they try to be lazy or energy efficient. One, cells are only going to synthesize or make enzymes when the substrate is available. Enzymes are there to break apart substrates or use substrates as building blocks. Well, our cells shouldn't make the enzyme if the substrate's not there. It takes extra energy just to make enzymes. It's still something you have to build. Why make the enzyme if there's no substrate to do anything for? Also, cells are going to catabolize or break down the more energy efficient choice if two energy sources are available. If there's two energy sources, one is easier to break down, like sugar, and will give you more energy, more bang for your buck to break it down, our cells are going to go for the easiest choice. Also, cells are going to synthesize metabolites. They're going to make molecules that they need and then stop making those if they're available. So if cells need something, our cells will make that substance, the metabolite. But if it's already there, we're going to stop, or the cells will stop. It's like, why make more of something if it's already there? If you already have it, why make more of it? And then the last part is the feedback inhibition, which kind of helps with this statement. Feedback inhibition slows or stops anabolic pathways when the product is abundant. During anabolic pathways, when you are building stuff, well, at some point, you might get to the point where you've got too much of that. You have an abundance of this product. Well, a lot of times that product becomes an inhibitor to one of the enzymes in the process of making it. And so that product becomes an inhibitor to stop the cell from making any more of the product. Let's make the product till we have enough of it, and then let's stop making it. It's like, we don't need to put extra energy into places we don't need to. Now, the last slide in your book, if you want a bigger version of it, in your book, it's on page 152. I just like it because these are going through the steps of metabolism. It's the breaking things down, the building things up of all the parts of our cells. Now, everything that has a purple arrow going to or from it is a catabolic pathway. It's breaking things down. And anything that has that greenish arrow is an anabolic pathway. Just about every particle or molecule in here is both a product and a substrate, or a reactant. There's so many things that are getting broken down, and then what they get broken down into is used to build something back up, or it could further get broken down. So our cells are constantly, and prokaryotic cells are constantly building things up and breaking things down and making these precursor molecules and all these other smaller things to then build up into something else. A lot of things going on in various types of cells. So I just wanted to end on that. I don't expect you to know that, but just a lot of different types of anabolic and catabolic pathways going on. So that's the finished up ending of the PowerPoint thing.